Hi everybody, welcome back to the Feynman Technique. Today I'm going to do my second video in the series Things We Take for Granted. And in this video, the thing that we often take for granted is the product rule for derivatives. It's something we use all the time. We don't really even think about it past a certain point. But I'd be willing to bet some of you watching this video right now can't derive the product rule for derivatives. Or maybe you could, but it might take you a while and you might need to look it up. But a couple things you need to know in order to derive the product rule for derivatives is the product rule for limits. And I'm not going to prove that. That's kind of a real analysis thing. But it's something that you're just given in calculus when you take a typical calculus class. Anyway, the product rule for limits states that the limit of a product of two functions is the product of the limit of those two functions. In other words, if you have two functions f of x and g of x, you multiply them together and then let x approach a, it's going to be equivalent to letting x approach a on the first one and then multiplying it by as x approaches a on the second one. And it's just written out right here. And that's called the product rule for limits. The second thing we're going to need to know is the limit definition of a derivative. That's pretty standard stuff. It's right here. But let's just get started. Okay, so to show this, what we need to do is we're literally going to plug in f of x times g of x into our limit definition of a derivative. So f of x times g of x prime is equal to, well, let's plug it into our limit definition of a derivative. That's going to be the limit as some value h approaches 0 of, okay, we have f of x plus h, but really our f of x is f of x times g of x. So that's going to be f of x plus h times g of x plus h minus f of x times g of x all over h, right? Okay, now I hope you would agree that we could add something to this numerator and then subtract the exact same thing from the, and then add back the exact same thing, and it would be equivalent. So that's what we're going to do. I'm going to extend this line out a little bit more, and then move our minus f of x times g of x over here. Okay. Now the thing we're going to subtract is, we're going to subtract, I need a lot of room here, we're going to subtract f of x plus h times g of x. And to keep the function equivalent to what it was before, we need to add that back. So, plus f of x plus h times g of x. Okay. Now let's rewrite this a little bit. I won't be copying this over because we're going to need a lot of room. So this is equivalent. Now we're just going to rewrite this. It's equivalent to the limit as h goes to 0 of, well, let's see. Let's put a parentheses around this. And then for this part, let's go ahead and factor out an f of x plus h. So this is going to be f of x plus h. And then we would have something over something else. That something would be g of x plus h minus g of x all over h. Then we would have plus, and in this one we're going to factor out the g of x. G of x, and then what would we have? We'd have something over for h, of course. And then we would have, let's see, f of x plus h minus f of x. Okay. That looks like an n. All right. So now we can utilize the product rule for limits. This, well, of course, we have to use the sum rule for limits. I didn't write that down, but that's pretty intuitive. So what I'm going to do now is I'm going to bring this, I'm going to distribute this limit. This is going to be the limit of this plus the limit of this. All right. So we have the limit, sorry, of this plus, and I should have given myself more room. So the limit as h goes to 0 of g of x times f of x plus h minus f of x. Okay, so I just transformed what we had before. Rewind the video if you're getting a little bit lost. Okay. Well, now we can use the product rule for limits on this, and we can use the product rule for limits on this. So this limit is going to be the limit as h approaches 0 of this times the limit as h approaches 0 of this. Well, what would that be? Well, the limit as h approaches 0 of this, of f of x plus h, is simply f of x. So this is going to be f of x times the limit as h approaches 0 of this, and that is from the product rule for limits. Well, what is the limit as h approaches 0 of this? That's the limit definition of g prime of x. So, times g prime of x. All right, and then we have plus this limit, so we'll say plus. Well, we have the limit as h approaches 0 of g of x. Well, g of x, okay, I'm sorry, we need to use the product rule for limits again. So this is going to be the limit of this times the limit of this. Well, what's the limit as h approaches 0 of g of x? Well, g of x does not depend on h, therefore h approaching 0 would be meaningless in it, and we'd simply be left with g of x, right? And then we would have times the limit as h approaches 0 of this thing. Well, that is nothing but the limit definition of f prime of x. And there we have it. This is exactly what you would have expected to get from this. Remember, f of x times g of x prime is the first times the derivative of the second. We have that right here, first times the derivative of the second, plus the second, g of x, times the derivative of the first. All right, there we go. There is the derivation of the product rule for derivatives. And yeah, that's something that we all use all the time, but I'll admit I forgot where it came from, and I was kind of interested to relearn it. So I got this derivation from the YouTube channel / website Khan Academy. I pretty much copied this directly from them, so I will link to their video in the description. Full credit to them for this derivation. But anyway, I thought it deserved to be on this channel, so I hope you enjoyed that.